Welcome, everyone, and thank you for joining us for the third of our Ask the Engineers sessions, looking at the COP26 summit, which is in full swing in Glasgow. I'm Alok, science correspondent at The Economist. Today is Science and Innovation Day at the summit. So we're going to take the opportunity to discuss a specific technology that's been prominent in the news recently when it comes to solutions or potential solutions for climate change. Hydrogen forms a key element of the UK government's net zero strategy. And governments actually around the world are also interested. It's an energy carrier rather than a source of energy. Once produced, hydrogen is high density fuel that can be stored and transported to wherever it's needed. Now, transport is one of the areas that is currently heavily dependent on liquid fossil fuels. Hydrogen could be useful here, and we've already seen some of the first hydrogen buses at COP26, in fact. But is hydrogen really a game changer? Can we produce it cleanly? And could it help in other areas like heating in the home or in big industrial processes like steel making? That's all what we're going to discuss today in this session. We're delighted to be working with Arup as the technical partner for these discussions. Arup is synonymous with leading engineering design as it aims to shape a better world. We will also, as usual, be taking your questions. To submit a question, just type it into the live chat box to the right of your screen. You'll need to sign in if you haven't done so already, and full instructions on how to do all of that are in the event description. So do send us your questions throughout, and we'll come to them towards the end of the session, and I'll have as many questions as I can in the time allowed to our panels. Now let me introduce the panel for you today. We've got a fantastic group of people. Professor Rebecca Lunn is Professor of Civil Engineering at the University of Strathclyde. She's an experienced government advisor and member of the National Engineering Policy Centre's Net Zero Working Group. Matt Williamson is Vice President of Hydrogen at BP. He leads a global team developing low-carbon hydrogen projects, including the UK's largest proposed hydrogen project on Teesside. Dr. Enass Abo-Hamed is co-founder and CEO of H2Go Power, a spin-out company from the University of Cambridge developing energy storage technologies. She's also a member of the Academy's Enterprise Hub and is on the board of Beyond Net Zero. Last but not least, Martin Pei is Executive Vice President and Chief Technology Officer of the Swedish steel company SSAB. This year, their joint venture, Hybrid, made the world's first customer delivery of fossil-free steel, produced without using coal. So welcome to our panel, all of you. I'm going to start by asking each of you just to answer our key question for today in 2 minutes, one by one, as a way of introducing yourselves and also some of your thoughts on the topic. So, Professor Rebecca Lunn, I'm going to come to you first. Is hydrogen the silver bullet that'll help achieve net zero?
So I would say hydrogen is not the silver bullet, but it is vital. So it is something that we need to achieve. So the key thing to remember about hydrogen is that, as Alok said, hydrogen is not a source of energy in itself. We have to produce it. It is a way of storing and transporting energy in a very high density way. And there are a number of industries that will need to rely on it because they can't use renewables. And examples of that might be aviation, shipping, and some industries such as the steel industry, where you require very high temperatures. The difficulty with hydrogen is how you produce it. It's producing it in a low carbon way. At the moment, we produce what is called grey hydrogen, which we produce from methane, and that process emits CO2. So that's no good for a future of net zero. Then there is the one option is to capture that CO2 and to store it under the ground so that that can become a net zero technology, but that has challenges. We would produce how we do now from methane. Methane as a gas is 80 to 90 times more potent as a greenhouse gas than CO2. So we need to make sure that doesn't leak. We need to make sure we can capture all of the carbon, and we need to make sure we can store it for thousands to tens of thousands of years for that to be a success. And then finally, we can produce what is called green hydrogen. And that's obviously where we want to get to. That's truly low carbon hydrogen, and the fact there's no carbon involved in the process at all. It is through electrolysis of water. So we would use renewable energy to split water into oxygen and hydrogen and to produce hydrogen that way. But it takes a lot of energy on current technologies to do so. We need a lot of excess renewable energy left to do that. And we don't have a big industry at the moment because that is quite an expensive way to produce it. So we need to grow that industry very quickly.
Becky, thank you very much indeed. Now, our next, that same question to Matt. So Matt, is hydrogen the silver bullet that will help achieve net zero?
Thanks, Alok. So hydrogen may not be the one silver bullet, but it's definitely one of a number of golden arrows. Our CEO, Bernard Looney, is a massive supporter. He has declared BP to be all in on the energy transition, and hydrogen is a key part of the transition, but not the only part. Renewable power, biofuels, carbon capture are also part of it. We expect in a net zero world that low carbon hydrogen will be the same order of magnitude as gas is today. And we think that's a business that's worth being part of. We've got a bold goal for BP in low carbon hydrogen, 10% of the market in core geographies by 2030. That's far higher than our share of oil or natural gas. And it's a vivid example of the fact that we are in transition to new forms of energy. We're going to be producing low carbon hydrogen, both green and blue. Our simple goal is to produce low carbon hydrogen for as low a cost as possible and as soon as possible. We've got a global activity set, and that feels right. Climate change is a global problem. We need global solutions. Here in the UK, we are using and developing hydrogen to decarbonize the Teesside industrial cluster, and we hope this can be replicated worldwide. We don't know all the answers, so we're partnering with others who are equally committed to low carbon hydrogen. This includes technology partners such as Daimler. We're working with on building out truck infrastructure. We're working with customers, a lot of industrial customers in Teesside and beyond. And lastly, governments. It's heartening to see governments across many continents making progress on low carbon initiatives. Looking forward to the conversation. I always find it a learning experience. Thank you.
Thank you very much, Matt. And next is Dr. Enass Abo-Hamed. Enass, what do you think is the answer to that question? Is hydrogen the silver bullet that will help achieve net zero?
In addition to what's already been said, well, first, I agree with everything Becky said, and she gave a really nice introduction. So hydrogen can be a silver bullet in some industries that need fast transition and transformation rather transition. So, for example, if we look at long duration energy storage, where you don't have many alternatives apart from hydrogen. If you're generating a green hydrogen that is generated by renewables, say in the winter, and you wanted to store it for the summer, there aren't many alternatives. So in an example like that, hydrogen could be a silver bullet. In many other industries, hydrogen will be, part of the mix. In some industries, it will be a leading candidate. In some others, it won't make sense to have hydrogen as the leading candidate. So, in summary, in addition to what's already said, it's a very, very important pillar in the energy transition, and it's very vital. And I'm very glad that we're having this conversation today.
Thank you very much, Enass. And last but not least, Martin, same question to you. Is hydrogen the silver bullet that will help achieve net zero?
Yeah, the steel industry is right now part of the problem because the steel production technology widely used worldwide, making steel from iron ore emits a significant amount of carbon dioxide. and we know that steel is extremely important material for the zero carbon economy. So steel needs to become part of the solution and get rid of its own emissions. Hydrogen is possible to be used to reduce iron ore instead of that we today use coal for the same work. And with the hydrogen replacing coal in the iron ore reduction process, we address the root cause for CO2 emission for the steel industry. We have started this process since quite some years. Back in 2016, SSAB teamed up with LKAB mining company, Vattenfall, the energy company in Sweden, and we made extensive research work, and we invested in the pilot plant program that we have been running since last year. As you mentioned in the introduction, that we made the first delivery of fossil-free steel to Volvo Group, who made the first vehicle using this steel and showed to the world just 3 weeks ago. So now we have shown that the technology works at the pilot plant scale, and our plan is to implement this technology at our first steel plant in Sweden in 5 years. In 2026, we hope to have commercial deliveries of steel products made with this technology. We are getting away with about 10% of Sweden's national emission if we implement this in our facilities. And this now we have got a lot of attention from our customers that see that they can decarbonize their product portfolio. So we see this is technically possible. So now we are really in the stage of implementing this at a large scale.
Thank you very much, Martin. If you're joining us now, we're talking about hydrogen and how it can help with achieving net zero. And we've just had our introductory introductory thoughts, and the message I'm getting so far is that hydrogen seems to be a potentially very useful plank in achieving net zero, but it's going to be one of many. And let's discuss how it's going to be important in the next 45 minutes or so. Now, hydrogen is the most abundant element in the universe. It's highly reactive, and so on Earth we find it mainly in water and in methane. Now, to be used as a fuel, of course, it needs to be separated into pure hydrogen. Rebecca, you said about you talked about the different ways we have of producing pure hydrogen. Blue hydrogen requires, which is one of the methods, requires carbon capture and storage to make it net zero. Can you just quickly explain how you make blue hydrogen, what the terms blue hydrogen, green hydrogen, all these things mean? And are the other technologies we need to make the net zero happen, carbon capture, for example, will they be ready in time for the net zero targets we have?
So blue hydrogen, as you said, is you produce hydrogen from methane and you capture the carbon and store it. And carbon capture and storage processes have been developed. They've been developed over the last sort of 10 to 15 years. And there are, in terms of geological storage, there are operating fields. But at the moment, it's an extremely small industry. And we have to demonstrate that we can capture and store carbon reliably for long timescales over the scale we require for global production. And that demonstration is not there yet. And one of the challenges in that is, where do you put it? If you use ex-oil reservoirs, which is some of the proposals to pump it down underground in ex-oil reservoirs, there are a number of complications involved in that, and the fact that you have disturbed the reservoir already, you may have fractures, it could leak. So there are examples where we are already storing, but to demonstrate we can do it at the scale required to meet a global industry, I would say that we're not there yet. You asked about green. Again, there are pilot plants. There are small hydrolysis plants. We are producing hydrogen in that way, but it's something that we need to make more energy efficient as technology develops. And again, we need to show that we can scale up production to the required level to meet global demand.
Thank you, Becky. Matt, your company's operations on hydrogen are based in Teesside. Tell us what makes Teesside so interesting and central to the hydrogen economy, and what's the sort of plans for that area?
Yeah, so I should say we make hydrogen globally. Unfortunately, at the moment, it's not low carbon hydrogen, and that's our challenge. So Teesside will be the first large scale low carbon hydrogen that we produce, which is the way we need to do all hydrogen in the future. So Teesside I think is a great example of where the UK government is getting it right on low carbon. I think governments get a hard time, so it's important that when they do something good, we recognise it. So the Teesside Industrial Cluster, linked with the Humber, represents about 50% of the UK's industrial emissions, and those can be stored offshore the UK safely and securely. 20 million tonnes a year, which is roughly equivalent to the CO2 produced by 7 million UK households. So we're talking about a truly global scale project here. Hydrogen is part of that. So capturing CO2 from industrial units is part of the solution, but hydrogen gets to the other parts that carbon capture can't work for. And that will be high heating applications. It will be development of local hydrogen transport. And I think this can be done and is achievable. So the government is proposing what they call contract for difference contracts for hydrogen production, which will mean producers can afford to produce it and customers can buy it. And this is the mechanism that the UK government used to develop the renewable power business. 10 years ago, less than 10% of our power in the UK was renewable. Now it's over 40%. That's an incredible journey over a relatively short period of time. And that's why I feel that we should have some confidence, albeit we don't have all the answers, that we can make similar progress on hydrogen.
Okay, hydrogen can be stored under pressure as a liquid fuel, and it could potentially be something that is a clean burning replacement for fuels like petrol and diesel that we're used to today. But we also know that hydrogen can be highly explosive and it can be dangerous if not handled with care. Enass, can I ask you, your company makes hydrogen on demand, on demand supply systems. How do you make sure that the supply of hydrogen, the storage is safe? What do you do to make sure of that?
So we are a storage company. We have developed a portfolio of technologies that look at storing hydrogen either in solid state or liquid state. The rationale behind doing that is eliminate the safety concerns from the operations when it comes to storage. So when you're converting hydrogen chemically for storage and you don't compress it, you've eliminated already 55% of the cost of storage. In addition to that, cost is a very important side to storage and to enabling an implementation of or proper growth of the hydrogen economy. So reducing the cost of storage is one side, but also enabling safe storage that will allow long duration storage that is safe and reliable is extremely important as we start talking about gigawatts of generation projects worldwide. We look at deploying these solutions into markets. One of them is hydrogen for energy storage. The other one is for commercial drones and flight. And these are two different applications that need storage that is safe and low cost, but they're very different in terms of what are the barriers. So for flight, you really need to be looking at light solutions, and for stationary solutions, you really need to be looking at cost competitive solutions.
Martin, can I ask you, steel making at scale, you've done your pilot plants, but you're going to try and do it at scale. That will obviously need huge amounts of hydrogen. How do you intend to store it safely?
Oh, yes. To replace coal for iron reduction, we will need a lot of hydrogen, and that's corresponding to how much carbon dioxide we can eliminate. The way that we are planning for our next step scale up is we will need to invest in electrolyzer plants, because in northern part of Sweden, Finland, we have good access to green electricity, mainly hydropower, but also increasing percentage of wind power. So our research work also include development of a hydrogen storage technology. We are currently building a pilot plant for testing of using the line rock cabin technology, which is currently used for storing natural gas. We will repurpose it, so we will store hydrogen in gas form at the pressure somewhere around 250 bars. So if we can do that, we can incorporate the with the electricity grid with a significant increased percentage of wind power, so that we can store hydrogen when there is a lot of wind, and then there is less wind. We can use hydrogen from the hydrogen storage to make the continued production of sponge iron and then for steel production. So this is going to work integrated with electricity grid. With that, we believe this will create a possibility for wind power investing projects to get a better payoff of their investment, and for us as a steel maker can get access to a lower cost of hydrogen on average level. So we will create a possible solution for the whole industry. That is our thinking, and we believe this can support the whole transition for our industry.
Thank you, Martin. Becky, Martin's going to use the hydrogen for steel making, of course, but where else should we start thinking about hydrogen? Can we use it for domestic heating, for example?
So I think that would be the last place that you would look to use it, because it has other complications and it's not necessary. So there are other solutions for domestic heating. So there are issues around transport and the pipe networks and leakage, but more importantly, there are other efficient solutions for domestic heating. One of the biggest of which is that we should be reducing demand for heat in housing, which we really need to do. So we need to reduce demand, but there is also electrification solutions, ground source heat, district heating networks, for example, that are used ubiquitously throughout Scandinavia that we could use. So there are good solutions, but what we should be doing is focusing on using hydrogen in the industries where there are not good solutions, and trying to generate hydrogen locally, which is what's happening on Teesside to your industrial cluster. So use it for industries where hydrogen is really required and grow from there. And then if we end up with an excess of green production, then perhaps we can use it for areas where it's not so necessary, or as just purely a storage mechanism for renewables. That's clearly a way ahead that we should be using it. But yeah, not for domestic heating at the outset.
Okay, thank you. Now, if we can produce hydrogen efficiently and economically, then it could be a big economic opportunity, of course. Martin, for your industry, steel, what kinds of resources do you think we'll have to have in place to make for a sort of sustainable hydrogen-based industry?
Yeah, essentially, it's the access to large amount of renewable electricity, because that is where we will then use to make hydrogen from water electrolysis. So at the moment, the development of large-scale electrolyzer plants is still in the takeoff phase. So there we expect that that industry needs to get a very quick development in order to support the industry's transition. Essentially, for us, it's really the renewable electricity production, and then the electricity grid infrastructure that need to be built, which in many cases, especially in Scandinavia, takes a very long time to build. And then is this scale up of the electrolyzer capacity, because if you look at all the plans that are announced there will be a huge increase of demand for electrolyzer plants. So those are important factors for the steel industry to get rid of CO2 emission.
And Matt, do you see hydrogen becoming a global commodity in the way that oil and gas is today? You know, and if that's the case, is there a need for a global hydrogen market?
I think with hydrogen, the mantra will be start local and then go global. I spent the early part of my career working on shipping natural gas on boats, getting gas to customers to switch from coal to gas-fired power. And at that time, it was essentially a single producer going to a single buyer. 20 years on, that there is now a global trade of shipped natural gas, many customers, many producers, all interwoven. Hydrogen feels similar. Transportation is a big element of delivered hydrogen supply chain, which is why I expect initially production to be close to where the hydrogen is used. So in Teesside, basically all the customers are within 7 miles of each other. However, as costs come down and large supply hubs open up, we'll see this evolve. And things like a low carbon hydrogen standard will help, so that you can produce hydrogen in one geography and know that when you ship it to another, it'll be of an acceptable quality to the customer. Again, as there's more customers start using hydrogen and that gets encouraged, trade will grow. It's always on the fringes that trade starts. So the more customers we have, the more the trade will evolve. And transportation is going to be important. So there will be dedicated hydrogen pipelines that work in a safe way. There already are in the US. We'll see them build out across Europe, and also shipping hydrogen by marine boats will be important as well. So I wouldn't look for a global hydrogen market anytime soon. We start local, but by 2050, I believe it will be global.
We're going to go to audience questions very soon. So if you've not submitted a question, please do so now, and you can find out how to do that in the event description. But before we do, Enass, a question for you. You have set up a company in the hydrogen industry, and I just wonder if you could give some advice for other entrepreneurs. You know, what do you think are the main opportunities for entrepreneurs, especially in places like in the developing world? What are the opportunities for them to join this hydrogen revolution?
On the technology side, there are so many ends that still need to be developed and fully understood, and there are so many opportunities in a growing economy to look at that large companies don't look at, governments don't look at, which means that someone will have to come up with ideas to fill these gaps. And I feel very optimistic that people with knowledge and enough passion about making change happen could really take leading roles here. So this would be my advice to entrepreneurs. And in terms of what opportunities are there in the developing world, I think there are fantastic opportunities in terms of, because of the lack of accessibility and because of the loop of there is infrastructure or there isn't, a lack of infrastructure in many countries, and you don't really have to go through building grids first and then connecting people. You could go through an alternative route, and that is the opportunity. So developers will have a lot of opportunities to look at, where you can generate hydrogen on the ground and use it at the same spot, or look at expansion in small areas. There are so many opportunities in the developing world that would be very difficult to implement in the developed world, given the infrastructures that we do have, or that we do need to change or think about how to change that.
That sounds potentially quite exciting. Now we're going to go to questions from the audience. Just a reminder, you can submit questions in the live chat box to the right of the screen. You'll need to sign in if you haven't done so already, and full instructions on how to do all of this are in the event description. So please ask away, and we'll answer as many of you as we can in the last half an hour of this session. So the first question, we have a lot already. The first question is, do you think hydrogen will ever be commercially viable for cars due to the efficiency issues compared with battery electric vehicles? Lots of people talk about hydrogen in cars already as a fuel cells or other ways. I just wonder if anyone has any thoughts on how likely it will be that we'll see hydrogen as used in fuels for cars. Rebecca, I thought maybe you're a good person to start with this one.
Not at the moment, I would say. So I wouldn't like to say never, but I mean, both technologies are improving at pace. So battery technologies will become more efficient. I think if we can, because you have to generate hydrogen, and if we can get to a point where that is entirely green generation, no matter how efficient the technology becomes, you will lose energy because you're generating from renewables in producing it. So I would say probably not, and that it's much more likely that we will just get more and more efficient at electric vehicles, and we keep hydrogen for applications where the fuel density needs to be extremely high, of which there are many. So
Matt, can I ask you, just for people who are not in the industry, they might think, oh, well, BP, you have garages serving petrol right now. Will you be serving hydrogen in the future? Is that sort of a too far a leap?
So I'm going to sell hydrogen, low carbon hydrogen, to pretty much anybody who wants to buy it. So I agree that maybe cars aren't the first place you would put hydrogen. That kind of from a road transport perspective, heavy duty trucks where you need to have kind of a large amount of energy stored so you can run your truck all day, have kind of long range, long uptime, and zero carbon emissions. Hydrogen makes a lot of sense. The thing that makes me pause for thought is I went for a ride in a hydrogen car last week, and it was pretty cool experience, and I can imagine myself enjoying driving around in a hydrogen car knowing that it was a zero carbon alternative. So I would say there's so many bright engineers in the world, they may come up with a way of looking at hydrogen cars in a different way than maybe kind of I've seen them previously. So I wouldn't rule it out, but it's not kind of like at the forefront of hydrogen uses today.
All right. The next question, for the panel, do put your hands up if you want to answer this one. What wastes are generated in the production of hydrogen? I guess this is a question about how it's made, and we kind of touched on it earlier when we talked about blue hydrogen and green hydrogen, etc. But is there a simple way of answering this? What wastes are generated in the production of hydrogen? Matt, maybe this is a question for you, given that you're producing lots of it.
Well, I think maybe we've had the answer to it. I mean, if you're producing hydrogen through reforming natural gas, you've got to capture the CO2. That's kind of your waste product. And in most circumstances, for at scale production, we'd think that CO2 is going to be stored safely forever. There may be some uses for CO2, that there are already industrial applications for some CO2, but it's never going to be at the same scale. So it's really making sure that CO2 is captured, but also that we use the heat generated in the process as efficiently as possible. So we will see advances in the way that we produce blue hydrogen to make them energy efficient and to really ratchet up the capture of CO2. Done well, you should be able to get to a similar carbon footprint for both green and blue hydrogen, but the key is to do them well, and that's really what we've all got to aspire to, so we get to that as lower carbon as possible solution for as low cost as possible.
Thank you very much. This next question is, I think maybe Enass, you can tackle this one, perhaps at least part of it. Let's see what you think. Can hydrogen be added to the existing national gas grid? What are the metallurgical issues for the steel pipe, and what pressures will be required? It's kind of a storage question in some ways, and you know about that. Are there bits that you might be able to answer?
Yeah, definitely. So if we're talking about a blending mechanism, then yes, for sure, hydrogen will have a role to play. Now, how you store it is a question of how much hydrogen you're storing. Where are you generating the hydrogen? For like, what's the typical infrastructure that you have invested in, or you have in one place? In like different grid operators will have like different approaches and solutions for that. But one of the solutions that you could look at is generating it at with an electrolyzer, storing it at a certain pressure, and when you use it, you convert it to a different level of a pressure that is more suitable for conversion at the point of use.
Thank you. Becky, you've got your hand up. Would you like to add something to that? You're mute. Yeah,
Not
you're
to
muted.
that,
Yeah.
sorry, but to the previous question about waste. So
Yeah, please do.
We need to not forget that electrolysis uses rare earth metals. So green hydrogen production has mine waste associated with it and the environmental impacts of that. And we really, as do many renewables actually, and we need to bear in mind that we have a lot of distance to go to make that mining operation itself low carbon, and to make sure that we look after the areas where mining happens and that waste is not polluting and is not hazardous to the local population either. So we just need to beware of our metal resources that we require.
Thank you. Matt, did you want to add something as well?
I really want to just talk about the hydrogen into the grid. So for folk on the call who maybe are a little bit older might be able to remember Towns gas, which was a mixture of methane and hydrogen. So we have had hydrogen at relatively solid concentrations in our pipes in our homes before. So I won't get the exact number right, but sort of up to kind of like 20% is a number that we should be able to achieve relatively easily. And there's lots of pipeline companies who are working on higher concentrations, new pipelines, working on what it does. And that's part of the journey to work out whether that is the best way to bring low carbon energy to people's homes.
Yeah, indeed, town gas is what I was thinking of too. When in that question, now it seems like everyone on the panel wants to answer this question as well. Martin, you put your hand up too. What would you like to say?
Yes, I was just going to comment on the question regarding waste in hydrogen production. If you're focusing on water electrolysis, of course, the heat generation has been mentioned that we really need to take care of. I want just to point out the other aspect is the huge amount of oxygen that we are going to get as a byproduct. And if we can find a valuable use of this oxygen, it will improve the overall economy. So when we are talking about hydrogen as a solution, we need to think about the systematic approach from the integration, as I mentioned earlier, with the electricity grid, with the buffering possibility, with the intermittent generated electricity, to this storage. If you can make the storage have a capacity long enough to balance the wind power, for example, in a couple of days or even a week, that will create a lot of value. And then in addition to that, if we find the value for this huge amount of oxygen, that will improve the overall system efficiency drastically. So I think that are important to remember.
Thank you. Enass, last word to you.
Yeah, I also wanted to comment on the waste question and perhaps cover like a side that was not discussed. The conversation around comparing hydrogen to batteries keeps coming up. Although, really the point here is that we're discussing net zero and how to get there. But from a waste perspective, if we rely only on one technology and one solution and only focus on, say, efficiencies of batteries and say this is the best technology because it's highly efficient, we should rely on it, that means that we're going to exhaust one natural resource and produce a lot of waste. The raw material that you make batteries are very different for the raw materials that you use to make electrolyzers or other storage technologies. So actually using a portfolio approach where positioning matters and you're positioning the right technology to serve the right application, the right use case, means that actually you could reduce waste and reduce exhausting natural resources because of less reliance on one technology and more consideration into where to position these technologies. So here is an example of where, because of waste, we really need to think about diversifying.
Thank you, Enass. Next, we'll get to another question now, and I think, Martin, maybe you can tackle this one first. A viewer asks, could geothermal energy sources be used to produce hydrogen, or would it be too unreliable? And I'm asking you, I suppose, because you need a lot of renewable electricity for the steel making, and you are in a part of the world where there is a lot of renewable energy. So I wonder what you have to think about that.
So the question regarding thermal energy?
Geothermal energy. Could geothermal sources be used to produce hydrogen, or would it be too unreliable?
Yes. There are quite a lot of development activities ongoing in that area. I mean, essentially, if we can get the electricity, of course, then it's the electrolyzer, water electrolysis, then we will convert electricity to hydrogen. In terms of geothermal energy, there are today development work ongoing with high temperature electrolyzers using the solid electrolyte so that the say thermal energy can be useful in this electrolysis process. But I'm not personally very much focused in following those developments. Maybe some of other panelists could give a better answer.
Rebecca, could you add something to that question?
Yeah, so geothermal energy produces heat. At the moment, we talk a lot about electricity and renewable electricity, but actually 50% of the energy that we use in Scotland and something similar in the rest of the UK, a little bit less, but not much, is actually used directly in heat to heat our houses and our industries. So, some of that industry will require hydrogen, but every time you convert energy from one form to another, you lose some. So the most efficient thing to do with heat that we get from geothermal is to heat things, basically, and not to convert it, and to use it at a lower temperature so that we don't need to convert it. So really, we should be using that for something like domestic heating or heating greenhouses or other things that don't require that high energy density, because we'll lose it.
Thank you, Rebecca. Okay, another question. Is green or blue hydrogen energy generation more or less hazardous to personnel when compared to more conventional power plants? That's a very specific question, and I guess the question is asking just about the industrial process involved in making hydrogen as a source of energy. I wonder if anyone has any thoughts on that. I guess Matt, you're the man to answer this one.
Yeah. So I started off as a refinery engineer, and one of the first units I worked on used hydrogen that we made in the refinery, and we used it to reduce the sulfur in our fuels, which helped stop acid rain. So we're used to handling hydrogen safely and reliably. It's not just BP; it's across the industry. So hydrogen itself is not new. The aspect of it that is new is the low carbon nature of it. So I'm confident in the industry's ability to manage hydrogen safely, and we've kind of done all the bits of the production chain already. It's just kind of we're going to put it together in one continuous flow. So personally, this is one of those engineering challenges that I'm confident that we are to solve as an industry.
Good, thank you, Matt. Okay, let me see. There's a few more questions that have come in. Okay, so here's one. There are many areas where hydrogen can compete with other options such as electrification. What factors should we consider when deciding where to deploy hydrogen to maximize its value? I feel like several of you have already touched on this, but I wonder if you might want to underline any of the points. I think, Rebecca, something you said earlier about using energy in the form it's meant to be, that's most useful in that point, rather than converting it, sort of stuck with me. But how would you answer that question about where can hydrogen be used? It's often talked about as replacement for all sorts of things, but where can we can maximize its value?
So as I said, if you don't have to convert energy, don't do so, because you lose it every time. So what we want to do is initially we want to use hydrogen in the places where we really need it. And if we think about what we need to achieve here, as you mentioned earlier, Alok, only 40% of our current electricity is produced from renewables. And that electricity demand is set to rise really significantly. So we are going to take transport over to electricity because we're electrifying vehicles, and we have to take heat to electricity. So what we shouldn't lose sight of actually is the need to reduce the energy massively that we use. So what we should really be focusing on is energy efficiency. So in all aspects, we waste heat, for example, in many places, not just from houses, but in our water supply. We waste energy in a lot of places at the moment. So we need, as a first priority in our tree of things to do, we should be reducing what we need. Then we should be looking where hydrogen is, at what things really require it, and trying not to convert as much as possible. And the one thing we haven't mentioned here at all as well is some of the real need to improve our storage mechanisms. So we need hydrogen storage to store our renewables. That's a clear, at the moment, we're wasting excess renewables, so that's a clear win to use it for that. But storing hydrogen in gas form for a long time is really, really difficult. It's very light and it leaks. So we need people like Enass's work looking at liquid and solid storage to make that a much more reliable thing to do with it.
Martin, did you want to add something too?
Yes, regarding the usage of hydrogen, one good example, agree with Rebecca on the energy efficiency aspect is extremely important. For the steel industry, the primary interest to use hydrogen is really for these ion reduction. So we use hydrogen molecules instead of using it as a fuel source. That is the absolutely most valuable use of hydrogen, so that we don't convert it again to something else.
Thank you. Enass, I wonder if you could just run us through why hydrogen is such a hard thing to store. This is your field of expertise, and I feel like we've not really said it out loud. What is it about hydrogen that makes it hard to sort of keep in one place and transport around?
I call it the happy gas. It just doesn't want to stay in one place. So you need to bring a lot of molecules under pressure together to store them, and that is the problem. Hydrogen in its gaseous form, if you really need to store sufficient amounts per unit volume, then the compression is the conventional method to do it. And because we know that there are so many associations with compression that are bad for long duration storage, or relatively long duration, doesn't need to be years or months. We store it differently. Now, addressing your point about efficiency, hydrogen is the smallest molecule. So if you store it under pressure in any material, it's just gonna leak. And if you're storing it for longer, that means that you're going to lose more and more molecules over time. So you're starting from like X amount of molecules, you're paying for X amount of molecules stored, and then at the point of use, you're losing some of them. That's why you really want solutions that allows you to capture, especially when you're talking about large scale for long durations, to capture the majority of the hydrogen that you started with. Because anyway, as Rebecca mentioned, and as we all know, the process of conversion to store hydrogen or to store energy in the form of hydrogen, any conversion you make, you have losses. So your win in the game is about how you minimize your losses across that journey.
Thank you. Yeah, no, I like your characterization of the happy gas there, because it does want to just leave everywhere it goes, and it corrodes pipes and all sorts of things. It's not, it doesn't sit there pliantly waiting to be used, does it? Here's a good question, which I like, and I'd be curious to see who'd like to answer it. If we're going to scale up electrolysis to make hydrogen from water, is there a danger we could run out of clean water? Could we use seawater instead? I mean, this is a good question. There is a water issue in the world. We're using more of it. We're wasting more of it. We're polluting more of it. Is this going to just be another competition sort for the sources of water to make hydrogen? Who'd like to tackle that one? Rebecca, you've probably got something to say about this one.
Thanks. It will compete for water. But there are areas in the world like Scotland where we have a fair excess of water, so that might be somewhat less of an issue. So I think that is around co-locating hydrogen to places where water demand is not a huge challenge and the competition for water is not so steep. I mean, Matt may have something to say about this. They're looking at global supplies, but there is definitely an issue, particularly in some areas of the world.
Matt, did you want to add anything to that? I mean, I suppose Rebecca's point is that some places in the world have excess water, and so they might as well use it for something else. In that case, you can't transport that easily to somewhere else. So would you like to add anything to that?
Yeah, so I mean, once again, Becky's kind of like gone straight to the heart of the matter and given us, I think, the best answer. So we will make sure that we will only be producing hydrogen in places where we're kind of maintaining the water balance. So that might mean going down desalination routes if you've got low cost, low carbon energy to allow you to do that. And that can actually be a relatively small fraction of the overall cost of producing hydrogen. So on balance, there'll be places where we already have lots of water, and there'll be other places where we can utilize seawater. So I think that won't be a constraint on the scale of the hydrogen business.
Okay, just sort of related in a slightly different way. Have people worked out how much extra green electricity, assuming it's green electricity, is needed for large-scale production of hydrogen? The questioner posits it's probably a biblical amount. So does it require a coordinated energy strategy? Has anyone got any quick thoughts on this? Martin, you're nodding your head. What do you think?
Yes, there are quite a number of very good analyses we heard here at the COP meeting. Lord Adair Turner described the study carried out by the Energy Transitions Commission. So there are quite very good estimates of how much renewables that we will need to make this transition possible. So for anybody interested could easily find those analyses.
So the calculations have been done, but is it a lot?
It is for sure. It is a lot. At the same time, we also should see this as an opportunity, because this will drive a lot of investments, create a new business which will be more sustainable. So that is, of course, an important question to think about.
And Rebecca?
So how much it is depends on how efficiently we use energy. So there are some very big ifs in that question, I would say. So if we are, at the moment, we don't use energy efficiently at all. We don't even think about it. Historically, we have just produced as much as we fancied, really, and as much as we could afford. And we are deeply energy inefficient. So what we need to do is value energy in a totally different way as we move forwards and make everything far more energy efficient. And as we've already said, when you make hydrogen, you're converting energy, so you lose some. So you would only want to use it where that is a sensible and needed thing to do. So of which there is a lot at the moment. But so we need to manage our demand so that the demand on renewables is a feasible thing for the future and something that we can hit in net zero, basically.
So
yeah,
it does.
Strategy.
Yes, I was going to say the question had a good point there. It does require a coordinated energy strategy. Okay. We're in the last few minutes now, so I'll just throw a few more questions into the mix. This is a good one. Is there a possibility of extracting deuterium from the vast amounts of electrolyzed hydrogen? It would be a great resource for future fusion power. Now, this person clearly is thinking in the long game here, because future fusion power would be a solution to all these problems, of course. That's we're far away from actually it happening in real life. I love this question. Anyone want to speculate on this? Could you extract deuterium from the vast amounts of electrolyzed hydrogen? I'm sure you could somehow. Who would know how to do that between you all?
I'm happy to comment on,
yes, please.
This question, but it could be a very long discussion on its own, and I know we're running out of time. So I'll just explain why this is a long-term question. We really need to do a lot of things to get the hydrogen economy to work in terms of reducing cost, increasing demand, and this would be more on the side of a far future thing that we do once all of these things are gotten right. And I think there might be research questions that this would be a very, very interesting opportunity to look at. But maybe commercially, it won't be prioritized in the short term.
Does anyone else think we could be getting deuterium out of hydrogen? A quick yes or a quick thumbs up or a thumbs down? Yeah, maybe. All right.
Not before 2050.
Not before 2050. Yeah. If there was a fusion power plant to put it into, that would be a good thing for a start, wouldn't it? That would be something else. Okay. Maybe a final question then. And let's end on governments and tax. The UK and other governments have already said they're going to tax hydrogen when it's used in transport as for petrol and other fuels. Is this a good thing? Rebecca, I wonder what do you think? Is it a good thing or not?
I think so. In the long run, no doubt we will have to tax. In the short, because we will all be either using renewable. In the long run, you hope that everything will either be fully electrified or fully hydrogen. So in the long run, we will need to generate taxes to maintain our roads, etc., or we'll have to do it in another way. So we will have to think about it. But in the shorter term, we need to be encouraging these industries to grow and give an opportunity for low carbon technologies to take over transport. That would be my view.
Matt?
Yeah, I agree. So in some countries or states in the world, there's low carbon fuel standards which encourage the production of fuels with lower carbon. So there's actually sort of incentives for those lower carbon fuels rather than taxation. And I think that's what starts the progress of more car manufacturers or truck manufacturers will produce trucks that emit less carbon. So I think we have to start on that route, and then it's part of a bigger solution, how we pay for the cost of our roads and the upkeep of those roads.
Thank you. Well, we're coming to the end. I just wonder if Enass or Martin, you wanted to add 10 seconds onto that question. I feel like, the others have answered the question about incentives are better than taxation at this point. But do you have any further thoughts, Martin, Enass?
Yes, we believe that for the steel industry to take this risk of doing this transition, we really need to create a level playing field so that by that I mean that we need to stop subsidizing the fossil-based processes and encourage the zero carbon solutions. Otherwise, we will not get the transformation quick enough.
Enass, did you want to add anything? If
maybe just to add to that, I'd say perhaps like add a disclosure policy. Well, first measure, report, and then tax becomes based on progress, essential or important. But maybe take a bit of time to improve and make progress if we want to, and then look at taxation.
Okay, thank you all very much. Well, that's all we have time for today, unfortunately. But we will pick up our discussion again in a couple of weeks' time at the last of our Ask the Engineers panels. Join us to discuss the final agreements made at COP26, whether they will help to control climate change and the impact on long-term sustainable development. That's on Wednesday, the 24th of November at 6:30 p.m. Greenwich Mean Time. And the topic will be post COP26, what have we achieved and where do we go from here? You can see how to register via the link in the chat right now. There's also a link in the chat to a brief follow-up survey of this event. This link will also be shared in an email. So thank you very much in advance for your feedback. It always helps to make these sorts of events much better. Right, well, it just remains for me to thank our excellent panel today for answering all your questions. Becky, Matt, Enass, and Martin, thank you all very much. And thank you also to the Royal Academy of Engineering and to the technology partner Arup. And see you all again on 24th of November, when we'll be reflecting back on what we've learned during the COP26 summit. So for now, goodbye.